Hi everyone and welcome to Chem class. Today I want to look at empirical and molecular formula for you. And the first thing I want to do is show you how to do an empirical formula calculation. So now that we've looked at percentage composition by mass, the reason that that's important is once we know what percentage of a compound is a particular element, we can also take that information and work backwards to work out what the formula looks like. So in this example, we want to know what is the empirical formula of a compound containing 40% sulfur and 60% oxygen. And that was calculated by their mass. So just here, I've got a little rhyme that I use and I help students to support them in doing their calculations by following this. The first step is turn your percent to mass, then the mass to mole, divide by small and multiply till whole. I'm just going to model that with this particular example. So the first thing we do is we take whatever percentages we were given for each of the elements and we just turn that into a mass. Because essentially if I had 100 grams of this compound, 40 grams of it would be sulfur and 60 grams of it would be oxygen. And when we want to take things down to the mole and to ratio, it doesn't matter whether we're thinking of it out of 100 grams or 10 grams or 1,000 grams. So layout is also really important, which is very helpful for you in your calculations. So the first one is sulfur. So I'm going to list everything about sulfur under this particular side and everything for oxygen under this one. So the first step is to turn the percent to mass. So 40% sulfur means I'm now dealing with 40.0 grams of sulfur, and the 60% oxygen is 60.0 grams. Second step, turn the mass to mole. When in doubt, we always turn things into mole. So to turn our sulfur mass of 40 grams into mole, we use our formula that we know that number of mole is mass over molecular mass or molar mass. And so we're going to take the number of moles of sulfur to be 40.0 over 32.1, and our number of moles of oxygen. So I keep the notation, makes it really easy for our reader or assessor to understand what we're doing. And oxygen is 16.0. So into the calculator we get the numbers of moles for that. 1.246, and this one is 3.75. You don't need to worry about significant figures or anything. This is just in workings out. Okay, the third step is to divide by small. What does that mean? Third step means take the 2 moles or 3 moles or however many elements you have in this compound, look at them, and whichever is the smallest number, you will divide all of those moles by their smallest number. So the smallest number here is 1.246. So we will divide both of these numbers by 1.246. 1.246. So this means that you always get something that comes down to a 1. In the calculator, this tells us it is 3. Now, if it was something like 3.05 or, something that is quite close to a whole number, you just round it off to the whole number. The last step, which is multiply till whole, doesn't apply in this particular example. It applies when you have something such as like a 2.5. We can't have 2.5 oxygens in our empirical formula, so we'd multiply it up by 2 and we'd just double everything. So it's really, that fourth step is just about making sure you've got whole numbers. If you have to multiply the whole line up, then you do so. So in this particular example, we're just about there. It's telling us that there's 1 sulfur for 3 oxygens. So our final answer, our final empirical formula is SO3. Please don't forget to give your final answer in these questions. Don't just leave it as this. That's your workings. It's not your empirical formula. Okay, let's now understand what we can also do in our calculations when we have an empirical formula and we're trying to work out a molecular formula. So let's first look at this. The empirical formula for something could be CH2. So empirical formula means it's the lowest ratio. For every 1 carbon, there's 2 hydrogens. It's a 1:2 ratio. But it doesn't tell us what the molecular formula might be. So what does this molecule really actually exist as? It could exist as C2H4 or C5H10 or any other combination of C's where the number of hydrogens is double it. So in this example, we can see that when we're given one more piece of information, we can actually work out the molecular formula. So if the empirical formula is CH2, as it is in this example, and the relative molecular mass is 56, what is the molecular formula? So we're trying to work out what's the molecular formula based on what it weighs, or what its relative molecular mass is. So the way that we would go about that is we take what we know the molecular formula has as a mass, and we divide it by what the mass of the empirical formula is. So if we know the empirical formula is CH2, 1C plus 2 hydrogens, that's 14, and they've given us the 56. So we take the 56, we divide it by the 14, and what we get is 4. The whole number that you get when you do the molecular formula over the empirical formula tells you what multiplication factor you need to do to your empirical formula. So if I'm going to take my CH2 and I'm going to multiply everything by 4, it means that my molecular formula is C4H8. Hope that helps.